Okay, two other little terms that I want to talk about, and then that'll leave us to finish compound lenses, to do the lab, and to talk about how the eye works. Okay, the first one is spherical aberration. We already talked about it in mirrors. Remember, spherical aberration was when you had a concave mirror, or a convex, but in this case a concave. And remember, parallel light rays were supposed to go in parallel to the principal axis and come out through F. But what we found was that if they were striking the outer edge of the lens, then they were crossing the principal axis before F. And the result was you were getting a blurry image. Okay, that was spherical aberration, and the way in mirrors, and the way we could fix it was either by only using the center part of the lens, or by making it, instead of a spherical mirror, making it a parabolic mirror. So the good news is, exact same thing, good news or bad news perhaps, the exact same thing happens in lenses. Okay, so rays that are going in parallel to the principal axis are supposed to get refracted in such a way that they will pass through, that was really supposed to go through F, but there was something on my sheet underneath my paper. They'll pass through F on the opposite side of the lens. Okay, but just like with mirrors, sometimes if they're striking the lens too far away, where the curve is not as big, they don't get bent the right way, and so they'll cross before the F. And just like in mirrors, the result is a blurry image. And just like in mirrors, the two way you can fix it is either to just use the center part of the lens, or to use a parabolic lens. Okay, so that's spherical aberration, identical to mirrors. The one that doesn't exist in mirrors but does exist in lenses is called chromatic aberration. And I would think that either in physics or bio, you might recognize the chromo. Chromo means color. So chromatic aberration happens because of the way different colors of light get bent. Okay, if you remember from grade 11 physics, different colors of light, they all travel the same speed in a vacuum, but in other media they do not. So different colors travel at different speed. And so the result then is a ray that's coming in, a white light that's coming in, inside this lens, it actually gets separated because the different colors travel at different speeds, different densities. And so because of that, they all get bent a different amount. And so we draw it as if the white light all stays together. But if we had our image here, what you could very well see would be like this fringe of color around it, because the violet light would bend more and it would focus before the principal axis, whereas the red would focus further away. Okay? And so you get then this fringe of color, and it's called chromatic aberration. Really, about the only way you can fix it is by putting, if you have a converging lens, by putting a diverging right after it. That would then put the colors back together. Okay? It will also happen if you have a diverging, a concave lens by itself. It too will cause the light to separate into its colors and give you an image with a fringe of color around it. Okay? So that's what chromatic aberration is. All right, I'm going to leave the eye for when we're in person because it's really cool, and I know you'll have a ton of questions and it'll be way more fun to do together.